Good afternoon, everybody. Thank you for joining us today. You're welcome to our live session today. We're going to be focused on 8th to 12th graders today, and I am looking forward to spending the hour with you. And feel free to send your questions in. If you have any questions related to things you're working on in school, please send them across, and be glad to work with you. So I have a few questions for 8th graders all the way to about pre-calculus. And feel free to send, if you have any topics that you feel like you really need help with that are outside of the topics that I'm covering, please let me know, and then I'll be able to get some questions that are relevant to those topics, and then we can work through them. I know that most of us are going through distance learning right now, and you may need help understanding some things that you have to know for some of your quizzes. So if you need help with that, please let me know, and then we'll be able to help you out with that as well. So how's everyone doing today? Good afternoon, Esther. It's good to have you. So I have some problems today I have a few word problems. I have some algebra problems as well. And then at the end of the session, we're going to have some quizzes, some puzzles that we'll be able to walk through. Good afternoon, Jaden. Thanks for joining. All right, so we'll wait for a few more minutes, and then we'll be able to get started. Do we have any 8th graders signed on yet? 8th graders? All right. So Esther, how are you doing with school? Jaden, how are you doing with school? Are you enjoying the distance learning? Is it challenging for you? What's your experience like so far? Okay, so while we wait for everyone else, let's go ahead and get started. We're about 3 minutes in already, so let's get started with some of the problems we have. If as we walk through these problems you have questions, please let us know. Let us know, and then we'll be able to guide you through, and also see if we need to give additional questions of the same type that we can walk through until you understand it. All right. All right, Jaden. Okay, so let's get started. So we have a question on averages, mean. So this is a word problem. So the average of 4 numbers is 18. If the numbers are x plus 3, 2x minus 5, 4x minus 9, and x minus 5, what is the value of x? This is for 8th graders, testing your knowledge of averages and means. If you happen to be in 7th grade pre-AP, you should be able to do this as well. And if you're not sure what to do, just let me know, and then we'll walk through this together and try to get to the answer. Okay. All right, let's see if anyone has... Okay, Anastasia, not a problem. I'll show you all how to do it once I feel like we've given enough time for some of you to try it out. So let's remember what averages are. Like, how do you calculate the average of a set of numbers? So the average, or we call it the mean. Okay, let's go ahead and do this together. Let's start with this. Whenever you're working through math, always start with what you should know, or what are the, you always have to start, you need to have a starting point. And here, the starting point here is to understand what average is, or the mean is. So the mean is actually the sum of all numbers, the sum of the numbers, and then we're dividing that by the count of the numbers. So what that means to us is that we're going to add all the numbers together, and then we're going to count how many numbers we have. In this case, you already have that answer, it's 4. So we're going to count how many numbers we have, then we divide the sum by the count. So in our case, the count of the numbers is 4. So what we're going to do here is our average, which is the same as the mean, is going to be the sum of all our numbers. We have x plus 3 plus 2x minus 5 plus 4x minus 9 plus x minus 5, and then we're dividing all of this by 4. So that is the starting point for what we're going to do with this word problem. And so the next step you're going to do is, you already know what your average is. Your average here is 18. So 18 is equal to, now we're going to add all these terms together. So we're going to say x plus 3 plus 2x minus 5 plus 4x minus 9 plus x minus 5, and we divide by 4. And you know that when you have a problem like this, you want to add common terms together. So all your common terms, you add them together, so you have 18. So we're going to put everything that looks like an x, we're going to bring them together, and everything that doesn't look like an x, we push them to the other, we push them away, okay? So we're going to say x plus 2x plus 4x plus x. So what I've done here is I've picked out these ones right here. So we have this, and then we now bring the numbers together. So we say plus 3 minus 5 minus 9 minus 5. And we're going to divide this by 4. I hope this is making sense so far. Now we continue, 18. Now we're going to add all of this together. X plus 2x, that's going to give you 3x. 3x plus 4x is going to give you 7x. 7x plus x is going to give you 8x. And then we have 3 minus 5. 3 minus 5 is going to give you, we have a plus minus here. So we're going to subtract the numbers. We have 2. The negative sign is on the larger number, so we get negative 2. So we have negative 2 minus 9 minus 5. So all of them have the same sign, so we're just going to add all the numbers together. 2 plus 9, that is 11 plus 5, we have 16. So it's going to be negative 16. So at 8x minus 16 over 4. Okay, so therefore, we have, this is going to give you 8x minus 16 over 4 is equal to 18. So now we're going to find a way to, let me create some more space on this so that, all right, so now we have 18 equal to 8x minus 16. Now we're going to solve this equation. How would you go about solving this equation? The easiest thing to do here, you have two choices actually. You can try to divide each term here by 4, or you can just multiply both sides by 4 to get rid of the fraction. And then you have 72 is equal to, because you're getting rid of the fraction, so you have 8x minus 16. And so we're going to add 16 to both sides. And we have 88 equal to 8x. And so let's come over here. So we have 88 equal to 8x. So we're going to divide both sides by 8. Divide both sides by 8. We have 11 equal to x. So therefore, 11 is equal to x is what's going to make this statement accurate. Does everyone understand what we just did? Is there any part of it you would like me to go over again? Everyone understands this? Is it clear? Is there any part of it that is fuzzy? You need me to... Okay. Thank you, Daisy, for joining. It's good to have you again. All right, let's go to the second question, since everyone is clear. Now, what we're going to do here is we're going to find the roots of 4x squared minus 28x plus 49 equal to 0. This is algebra 1 and algebra 2. So if you have learned the quadratic formula, you can use that for this. If you have learned how to factor, you can also use that for this. So regardless of which approach you use, you should be fine. What are the roots of this quadratic equation? All this is simply asking you to do is to find the values of x. That's all it is. When it's asking you for the roots, find the values of x. Do we have algebra 1 and algebra 2 students here today? Okay. So for those who want to use the quadratic formula, here is what the quadratic formula looks like. Negative b plus or minus square root of b squared minus 4ac divided by 2a. Good afternoon, Ini. That's possible. That is very possible. Let's wait for a few more responses. Good try, good try. I like your part. I'm enjoying the participation. So we'll wait for a few more responses and then we'll get going. All right, so let's go ahead and do, I'm going to see if I can do the two different approaches. We're going to use the quadratic formula and just factoring. So let's go ahead and use the quadratic formula first. It's always the easiest way to go if you know how to use it. So what I always like to do is I start with ax squared plus bx plus c equal to 0. This is what we call the standard quadratic equation. And what I'm going to do now is I'm going to compare it with the equation that I got initially. So if you compare ax squared plus bx plus c equal to 0 with 4x squared minus 28x plus 49 equal to 0, you can see that a will be equal to 4, b equal to negative 28, and then we have c equal to 49. So now we're going to go ahead and substitute this information here into the equation. So we now have x is equal to negative, b is negative 28 plus or minus square root of negative 28 squared minus 4, a is 4, and then c is 49. Okay, and then we divide by 2 multiplied by 4. So now we're going to simplify this, and we're going to have, this is negative here is going to make this positive 28 plus or minus the square root of negative 28 squared. So let's go ahead and figure what that is. 28 multiplied by 28. We're going to have 64 here, so we write 4, bring 6 up here. 16 plus 6, 2, 24. 0, 2 multiplied by 8, 16, 6, bring 1 up here. 2 multiplied by 2, 4, plus 1, 5. We add this up, we have 4, 8, 7. So this is 784 minus 4 multiplied by 4, 16. 16 multiplied by 49, I'll tell you, it is 784 as well. 16 multiplied by 49 is also going to give you 784. So this is going to be 144,046. So this is 784. So we have 784 minus 784 divided by 8. So this is now going to give us 28 divided plus or minus 0, because square root of 784 minus 784 is 0, square root of 0 is 0, and then we divide that by 8. So this is going to give you 28 divided by 8, which is also going to give you 7 over 2, which is 3.5, or 3.5. So Ini was correct. So that's one way to do it. The other way you can do this is to just factor the quadratic equation. Let's go ahead and do that. We have 4x squared minus 28x plus 49 equal to 0. And so here we need to find 4 multiplied by 49, that is 196. So we have 196. We want to find the two factors of 196 that give you a sum of negative 28. That's going to give you negative 14 and negative 14. So when you have bigger numbers like this, if you can use this quadratic formula, it's easier. Otherwise, you have to do a lot of manipulation of numbers to get to your actual factors. So you have 4x squared minus 14x minus 14x plus 49 equal to 0. So now we're going to factor by grouping. So I'm going to group this together and then group this together. So let's factor each of them. We have 2x here as a common factor. Then we have 2x minus 7. And then we have here as a common factor negative 7. And we have 2x minus 7 equal to 0. So therefore, our factors are going to be, the greatest common factor of this expression will be 2x minus 7, and the other factors are also 2x minus 7. This is equal to 0. So that means that 2x minus 7 is equal to 0. And then we add 7 to both sides, and we have 2x equal to 7. Divide both sides by 2. X equal to 7 over 2, or 3.5, or 3.5. So here you can see that regardless of how you go about it, you will end up at the same spot. So it depends on which of these types of approaches you prefer. I like to say the easier the better. So if you can use the quadratic formula, go ahead and use it. If you prefer to do factoring, go ahead and factor. Are there any questions on this? Is this clear? Do you want me to do another example like this? All right, so let's go ahead to the next one. Oh, this is wrong here. So we're looking at if the product of two numbers is 48 and the sum of the numbers is negative 19, what are the numbers? The product of two numbers is 48 and the sum of the numbers is negative 19. What are the numbers? This is actually system of equations. System of equations. So we're testing here your ability to look at word problems and then create a system and solve a system. Is anyone familiar with this type of problem? Good try, Jaden. 2 and 4. So the product of two numbers, we have two numbers. When you multiply them together, you get 48. When you add them together, you get negative 19. What are these numbers going to be? Okay, let's go ahead and try. Let me show you how to go about this. The easiest way to think about this type of problem is, let's assume that our numbers are x and y. Very close, Esther, very close. But you have to check if 16 plus 3 is going to give you negative 19. That's the part of it that I think you have missing. But you're on your way there. You're actually on your way there. Good try. So what we're going to do here is, I'm going to say the numbers are x, perfect, Esther, x and y. So we have the product of the two numbers. Product means multiplying the two numbers. So x multiplied by y is equal to 48. So we can write this as xy equal to 48. Then the sum simply means that you're adding the numbers together. X plus y equal to negative 19. So now we have a system. This is going to be the first equation of the system. This is going to be the second equation of the system. Now what I'm going to do here is we're going to use the process of the substitution method. So what I'm going to do first is try to figure out which of these I want to solve for. So I'm going to solve for y. So y is going to be equal to negative 19 minus x. So I now have the value of y. I'm going to now substitute that value of y into, let me actually use a different color so you can see what I'm trying to do. So we're going to substitute the value of y into this expression over here. And we now have x multiplied by y. Y is negative 19 minus x equal to 48. So now we're going to distribute x into this, and most likely we will form a quadratic equation. So negative 19x plus x squared equal to 48. And then we always, with quadratic equations, you always want to write it in this form. Ax squared plus bx plus c equal to 0. So that's our next assignment here. So we're now going to write it in that form. So we're going to have x squared minus 19x minus 48 equal to 0. So now this is the expression we're going to factor. So this is the equation we're going to factor. I'm going to use the quadratic formula. So we have x equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. This is a good habit to form. Before you do anything, try to write the formula so you can at least know what you're working toward, and if you make an error, you can easily spot where your error is. So we have here, in this case, we have a is equal to 1 because there's no number to the left of x squared, so you can always assume that to be 1. A equal to 1, b equal to negative 19, and then c equal to negative 48. So now we're going to go ahead and find and substitute these values into the equation. So x is going to be negative b is negative 19 plus or minus the square root of b squared is negative 19 squared minus 4. A is 1, c is negative 48. And we're going to divide this by 2 multiplied by 1. So that's the setup of the equation here. And so the next step is to simplify. So negative 19 is going to be positive 19 plus or minus 19 squared. Let's go ahead and try that. 19 squared. This is 81, 171,091. So we have 361 as 19 squared. So we have 361 minus 4 or negative 4 multiplied by negative 48. That's going to give you 4AC. Okay. Negative 4 multiplied by negative 48. That's going to give you 192. It's going to be positive 192. Let me check something here. Give me a second. Minus negative 19x plus x squared. Let's just go through. I want to make sure we're doing it right. So xy, y is negative 19 minus x. That's correct. So xy is x, y is negative 19 minus x. So we have negative 19x plus x squared. And then, okay, this comes here. All right, I think we're on the right track. All right, so we have negative 19 here. Something looks wrong here. X multiplied by y is 48. X plus y is negative 19. That's correct. So we have x negative 19 minus x. That is going to give you 48. Okay, looks right. Negative 19x plus x squared equal to 48. All right, that looks right. So this is x squared minus 19x. Then we bring 48 over here. It's minus 48 equal to 0. All right, so we have negative 19, negative b, which is negative 19, plus or minus b squared, which is negative 19, minus 4ac, plus 192 divided by 2. Okay, the equation looks funny. So, okay, let's go ahead and continue. So we have 19 plus or minus. Now we have 361 plus 192. So this is going to give us 3, 6 plus 9, 15, and 3 plus 1, 4, plus 1, 5. All right. The equation is wrong somewhere. Let's trace it back. The equation is wrong. So since we wrote all our steps, we should be able to get to our answer. So the product of two numbers, so we have x and y, that's correct. Then x plus y is negative 19. So we're saying that y is negative 19 minus x, that is fine. So xy, which is right here, we replace y with negative 19 minus x. So this is going to give us negative 19x, then negative x. That's the problem. So the problem here is we made an error. Negative x multiplied by x is negative x squared. That's the problem. So that's the problem here. Thanks for catching it, Esther. So I was rushing through it. So this negative x squared. And so what we have here is we can still use this. So that's fine. So a equal to -1. So we can still, everything else looks fine. And then we have -1 here. And so it's going to give us it's going to give us minus 192. And I think everything else we're on track. All right. So let's go ahead and find the value of 361 minus 192. This is going to give us a 5 here, 11 minus 2, we have 9. We have 2 here, 15 minus 9, we have 6. 2 minus 1, we have 1. So we have square root of 169 divided by 2. So I think this is a good reason why I always say make sure your steps are clear. Make sure you write everything out clearly so that you can follow through whenever you make a mistake. So I think I've been able to demonstrate that. So this is going to give you 19 plus or minus. The square root of 169 is 13, and then we divide by 2. So therefore, we have x is going to be equal to 19 plus 13 divided by 2, or 19 minus 13. And so we have a problem here as well, because here is, yeah, that's fine. So 19 minus 13 divided by 2. So this is going to give us 19 plus 13 is 32 divided by 2. 19 minus 13 is 6 divided by 2. So minus b. Let's double check this. Minus b plus or minus square root of, this is negative. Yeah, so once you make an error, you have to be able to check all your answers. So what the mistake I made here is when I changed this to -1, I forgot to change it here. So we have -2 here. And so we have -2. This is going to be negative. And so we have 32 divided by -2, which is -16. And 6 divided by -2, we have -3. So those are the values of x. Now let's go ahead and look for the values of y. We have to trace it back because we said y is equal to -19 minus x. So y is equal to -19 minus x. So let's go ahead and substitute each of these values of x. So y is equal to -19 minus -16, which is -19 plus 16, and that gives you -3. And then if x equal to -3, y equal to -19 minus -3. And so we have -19 plus 3, which is going to give you -16. So therefore, you can now see that the values of x and y are going to be -16 and -3. So what you can learn from the experience we had, so I made some mistakes in the steps, and it was just computation errors. So that's why I would always recommend to you that whenever you're working through a math problem, be as clear as possible when you're stating your steps, so that if you have to go back, it's a lot easier for you to fix any problems. Always think of math as building a house, so you have to make sure that you have a blueprint that you're working with, so that if you make an error, you know exactly where the problem is. So that was that. Any questions on this? Any questions? Does it make some sense to you? The most important thing is trying to make sure that you can create the quadratic equation. And once you can create a quadratic equation, you're halfway there. Okay, okay. So I'm going to skip a few problems because I want to get to, I think the next question I have here is a pre-calculus question, but I'm going to go to another 8th grade question instead. Okay, we have an 8th grade question. So if 9x and 41 make a Pythagorean triple, what is the value of x? If 9x and 41 make up a Pythagorean triple, what is the value of x? Pythagorean triples. Is that something everyone is familiar with or anyone is familiar with? So let me show you something here. So a Pythagorean triple is a set of numbers a, b, c such that a squared plus b squared equal to c squared. So a Pythagorean triple ABC, the Pythagorean triple is a set of numbers ABC such that a squared plus b squared equal to c squared. So with our set of numbers here, what this simply means is 9 squared plus x squared equal to 41 squared. And we need to find the value of x. So let's go ahead and I'm just going to subtract 9 squared from here. Subtract 9 squared. So x squared is equal to 41 squared minus 9 squared. Okay, you have two ways of doing this. You can go ahead and actually find out the value of 41 squared and the value of 9 squared and subtract them. Or if you remember what I showed you last week, a squared minus b squared is the same as a plus b multiplied by a minus b. So instead of going through the whole process of multiplying finding out what 41 squared is and 9 squared is and doing the subtraction, I'm going to do this instead. 41 plus 9 multiplied by 41 minus 9. So this is going to give you 50 and then multiplied by 32. So this will give you 5 multiplied by 32 is 160, and we add a 0 to the end. I hope you all have seen this method before. It's a method that allows you to save time whenever you're doing math. I always try to find the time-saving methods. So if this is a new method, feel free to use it. It will save you a lot of time on your tests. So therefore, x squared is equal to 1600 or 1600. Now, what do we do to get the value of x? We will find the square root of x. The square root of x. And I'm going to focus on the positive square root of x because our numbers are 9, x, and 41. So they're all positive. So the square root of x squared is x, and the square root of 1600, another method I try to use, 1600 is 16 multiplied by 100. So we can find the square root of each of these numbers, 4 multiplied by 10, which is 40. So the square root of 1600 is 40. So therefore, x is equal to 40. Any questions? Any questions on this? Is this clear? 8th graders, does this make sense to you? All right, let's go through one or two more. Okay. Thank you for your response, Esther and Ini. So let's go through one or two more Algebra 1 or Algebra 2 questions, and then we'll get to our puzzles for the day. So we're looking at radical equations here. The square root of 6x minus 3 is equal to the square root of, is equal to 3 square root of 5, or 3 radical 5. What is the value of x? We're trying to solve for x here. What is the value of x in this case? To approach this question, you want to first find out what do you need to do. See, you have a radical on both sides, and they're both square roots. So the question to you need to ask yourself is, you can't really do much with this the way it is. What are you going to do to make sure you can get rid of the square root? So this is what you have: 6x minus 3 equal to 3 square root of 5. So the easiest way to get rid of a square root is to square the number. So we're going to square these numbers. And remember, in math, when you have an equal to symbol, whatever you do on one side, you must do on the other side, otherwise it's going to throw you off. So here we have the square root of 6x minus 3 is, when you square that, all it does is it removes the square root sign. So you now have 6x minus 3 equal to, now in this case, you have to square every single part of this expression, this radical here. So this is going to be 3 squared multiplied by the square root of 5 squared. So you now have 6x minus 3. Okay, good try. Let's see if you're right. Let's check. You actually may be right. 6x minus 3 equal to 9 multiplied by 5. So 6x minus 3 equal to 45. And now we're going to add 3 to both sides. And then we have 6x equal to 48. Now we divide both sides by 6. And x equal to 8. Perfect. Yeah, Ini, you're right. Perfect. So let's try one more question. Let's try one more question. Let's see if we have an Algebra 1 style question here. Let's see, should we do that? Okay, let's do this one. So this is Algebra 2, and we're looking at, these are actually radicals, but they are complex radicals. So let's go ahead and try to do this question here. Remember that whenever you have a number under the square root sign that is negative, you're going to end up with an imaginary result. So this is -1. This is going to give you I. The square root of -1 is I. You can always think of it as I for imaginary, which means the number doesn't exist. So an imaginary number is a number that you cannot put it on the number line. That's the opposite. The opposite of that is a real number. A real number is any number that can exist on your number line from -infinity to +infinity. But for example, if you put this on your calculator, it depends on what you have, what type of calculator you have. You may get something like error because it doesn't exist on the number line. Or some older calculators will just write the letter E to show you that it's not able to do it. So what we're going to do now is we're going to first imagine that there's no negative sign under the square root sign. So the square root of 49, most of us know as 7. So the square root of -49 is going to be 7 multiplied by I. The square root of -64, using that method, is going to be square root of 64, which is 8, and then I. Now let's look at the square root of 72. For a number like this that is not a perfect square, let's focus on 72 and 50. These are numbers that are not perfect squares, so we have to represent them as radicals. So here we're going to have 72. You have 2 multiplied by 36. So actually you can stop here because you have a perfect square for 36 is a perfect square. So the square root of 72 is going to be the square root of 36 multiplied by the square root of 2, which is 6 square root of 2. So for negative 72, your square root is going to be 6i square root of 2. You can put it here, but just as a practice in math, we don't do it that way. We always combine the I with the number. So it's going to be 6i square root of 2. And then we do the same for 50. 50 will give you 2 and 25. And so we have square root of negative 50 is the square root of 2 multiplied by the square root of 25. So this is going to give you, it's going to give you 5 square root of 2, or 5i square root of 2. And so now let's create some more space, because I want to show you how to combine this together. So we have negative square root of negative 49 plus square root of negative 72 minus square root of negative 64 minus square root of negative 50. Let's go ahead and replace all of this with their their imaginary numbers. Here we have 7i plus 6i square root of 2 minus 8i minus 5i square root of 2. So we're going to group common terms together again. Common terms together. So 7i minus 8i plus 6i square root of 2 minus 5i square root of 2. So 7i minus 8i, ignore the I, is just, look at it as you're doing some algebra, look at it as an x. 7x minus 8x is going to be negative 1x, so this is going to be negative I. 6i minus 5i is going to be I square root of 2. So this is algebra 2, and this is there's some pre-calculus here as well. So I just wanted to throw one in for the 11th and 12th graders. And after this, let's go ahead and look at some of our puzzles. Are there any questions? Do you actually have any topics that you're going through in school right now that you want me to help you out with? We have some time that I can deviate from what I had originally. Do you have any topics that you're doing in school right now, or you're learning, or you're having difficulty understanding? If you do, let me know. And then if it's something that's going to take a lot of time, I will make sure that that's the first thing we do on Thursday. Okay, if we don't have any questions, let's go ahead and try out our puzzles for today. Money? What about money, Jaden? If you're more specific, it can help you. So we can look at our puzzles now, and then if there are any questions after the puzzles, we can take another look at that. So what is the missing number in the puzzle below? What is the missing number? Let's see. Okay, I'll wait for you all to... I chose some that were not too difficult today. Graphing quadratics in factored form. Okay, that will take some time, so we can do that. I will take note of that for Thursday. We'll do that on Thursday. Graphing quadratics in factored form. So you're looking at, let me write what I think you're looking for so that I can prepare something along those lines. So you're looking at y minus k equal to a x minus h. Is that what you're looking for, Esther? Something along those lines? Jaden is not hard. It's actually not hard. Anybody want to try this? It's actually not too difficult. Okay, let's give you 1 more minute and see if you can come up with an answer, and then I'll show you what to do. Okay, I see what you're talking about. All right, no problem. Let me write the example so I can work with that. No, it's not 1. Okay, so let me show you something here. So we have, so what I can subtract 1 from both sides, and then you have 2 cats. So a cat multiplied by a cat is going to give you 16. So what is the square root of 16? It's going to be the cat is equal to 4 units. Because, oh, good afternoon, Cheryl. Good to have you. So you have 1 plus 4 multiplied by 4. Remember, PEMDAS, multiplication comes first. And so when you multiply a number by itself and add 1 to that number, you get 17. That number is 4. Then let's look at the mouse. You have 4 here, and we need to 4 multiplied by 9 is 36. So each of this is going to be 3. So the mouse is equal to 3. And so now we have 4 multiplied by 3. And so you have 3 blocks of cheese going to be equal to 6. So 1 block of cheese is equal to 2. So now you have 4 minus 3 plus 2. 4 minus 3 plus 2 is going to give you 3. All right. Good try, everyone. I see everyone tried. Okay. You all are right. All right. So we have a final one. Want to find out the number in the middle. I'll give you a hint. The hint here is 1. Actually, I don't like that color. So let's do 1, 2, 3, 4, 5. That's the hint. One, two, three, four. Oh yeah, in a good try. That was good. That was good. Very good try. Anybody else have an answer? Good try, Jaden. Okay. So all right, Esther, everyone's got the idea. That's wonderful. So for those who haven't really figured it out, let me show you what this is. It says, I give you a hint, 1, 2, 3, 4, 5. There's going to be 1, 2, 3, 4, 5. This is also 1, 2, 3, 4, 5. So what you're seeing here is 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. The next one, 1 cube is 1, 2 cube is 3, 3 cube is 27, 4 to the third power, that's what I mean by cube, 4 to the third power is 64, and then 5 to the third power is 125. We're doing the same, but this time to the fourth power. So here, the missing number is going to be 5 to the fourth power, which is 5 multiplied by 5, multiplied by 5, multiplied by 5. This is 25 multiplied by 25. And the trick for perfect squares, to find the square of a number that ends with 5, is to write 25 at the end, multiply 2 by 3, you get 6. So that is how you get your answer. So this is 625. All right, that's all I have for today. Are there any questions before we call it an afternoon? Are there any are there any questions for me? I know, Esther, I have something I will be preparing for you for Thursday, but is there anyone else that has a question? All right, thank you all for joining me for the hour. I really enjoyed it. I enjoyed especially the opportunity to show you how to deal with errors when you're working through a math problem. Never think that when you're doing math, you're going to be perfect all the time. Sometimes you make mistakes, but I'm glad that you're able to see me make a mistake and then I had the opportunity to show you how to trace back your steps to address your mistakes. All right, so thank you. Have a wonderful day. I'll see you again on Thursday. Stay safe, and I hope you're enjoying school. Always remember that you can reach out. You can reach out anytime you have questions. I will be definitely glad to assist you with that, or to make sure that those questions that you send to me are brought into our 1-hour session. So have a wonderful day. Thank you again. Be blessed. Bye for now. Thank you, Yemi.